Low traffic density is the characteristic of a large part of the European network of railway lines whose signalling equipment is obsolete. Some of it dates from the 19th century when the lines were constructed. If at some point we want to continue the safe operation of these lines or increase their capacity, it appears mandatory to renew the signalling and the train control systems, trackside and onboard of operating trains.
Well, yes, it's true that for these lines, the cost actually of classical trackside signalling is really high.
The renewal cost could be so high that upgrade projects would be abandoned because of lack of efficiency and the lines end up being closed.
But, the closures reduce the accessibility of the concerned territories and therefore their attractiveness and contribution to economical growth.
It is not surprising that mainline efficiency could suffer consequences because of unavailable side operating branches, and obviously the closure of secondary lines pushes mobility to the other transport modes, contrary to sustainable development practices. These reasons motivated the European Commission to launch the project SATLOC. It aims to demonstrate that satellite-based navigation technologies enable train and traffic control on low traffic density lines with full safety at low life cycle cost and are compatible with the specifications of the European Train Control System ETCS. Coordinated by the International Union of Railways, SATLOC brings together specialists from railway undertakings, supply industry, including those specialized in space technologies, universities and research centers. Now, to understand why SATLOC is of high interest, it is worth knowing, even briefly, the principles of the European train control system currently applied. To continue its route, a train shall receive from the radio block center a movement authority which indicates the distance the train is authorized to travel. This movement authority safely considers the position of the other trains and the instructions of the control center which manages the train's movement. Thanks to the track-based train detection system, the radio block center receives the information about the line occupancy. And when passing over track balise, the train identifies its position and transmits it to the radio block center via the GSM rail radio. Depending on the system configuration, the updated movement authorities are transmitted to the train either via GSM rail or by the track balise.
With SATLOC, the system is very much simplified.
The radio block center and the control center have merged and have become a single entity, the Traffic Control Center, or TCC. There is no need for track-based train detection systems, physical track balise and their onboard reading equipment, and no trackside signals. The expensive and already aging GSM rail is no longer needed for data transmission. The train has an onboard computer, a satellite navigation receiver, a mobile radio combined antenna and a driver-machine interface in the driving cabin. The existing mechanical odometer, the speed measurement system based on computation of wheel rotations, is upgraded and fused with the satellite navigation data. The route map is stored in the memory of onboard computer and in the computing system of Traffic Control Center. The route map describes the rail topology in geographic coordinates. It is set in correspondence with the kilometric mileage and indicates also all line-defined speed limitations.
The route map includes also the virtual balises, which are marked references along the track with coordinate positions. They make SATLOC space reference fully compatible with ETCS.
Navigation satellites, today GPS, soon Galileo, the geostationary satellites of the EGNOS system and the public mobile radio networks play their role. The TCC transmits via mobile telecommunication network the movement authority in the shape of a safe message compatible with ETCS specifications. The train receives the navigation signals and also the EGNOS signals, which significantly increase the positioning accuracy and validate the position's integrity. The board computer calculates the train's position and speed each second with a high level of confidence. The board computer permanently verifies that the train enforces the movement authority's order and the speed limitations indicated on the route map. With valid navigation data, the mechanical odometer is permanently recalibrated. Every 5 seconds, the train sends its position and speed to the TCC. In turn, the TCC verifies the enforcement of movement authorities for each running train.
This real-time double check by the onboard computer and the traffic control center system is one of the major SATLOC innovations. We name it closed-loop control.
If the satellites are not visible, for instance when the train passes through a tunnel, the odometer takes over to calculate the position and speed. As the system is calibrated online, this data is quite accurate. And even if the train does not correctly enforce the movement authority and exceeds the authorized speed, the TCC can detect this malfunction and trigger the emergency stop order to the train.
The combination of geolocalization signals, augmented with and safely validated by EGNOS, the online calibration of the mechanical odometry, and the real-time exchange and check of position and speed between the train and the traffic control center, enabled to reach a high level of safety, which equals or is even superior to the ETCS-1.
After 2 years of research and engineering, SATLOC has been tested in real operational conditions on a low traffic density line in proximity of Brașov in Romania. The trains are fitted with the necessary equipment: combined satellite and mobile radio antennas, onboard computer, and driver-machine interface in the driver's cabin. Here is the SATLOC TCC with its computing and telecom equipment and the screens where the SATLOC tracks and all trains are shown. The train driver introduces the data on the SATLOC interface, and the TCC receives the train registration and the request for movement. The TCC responds and sends the train the movement authority indicating the safely selected and locked route. Once the train has received the movement authority, it can start its journey. Throughout its journey, the train sends its position and speed every 5 seconds and enables the TCC to know in real time where the train is. The TCC updates the movement authority in due time. SATLOC is an easily implementable and less expensive system for several reasons. First of all, no track-based train detection systems are needed. This task is safely undertaken by the satellite-supported train positioning. Secondly, taking into account the overall high level of safety supplied by the closed-loop train track interaction architecture, the system components can be used through less costly procedures. This is the case with computing equipment. Also, the data transmission uses a secure virtual private networking technology on the public mobile networks. Therefore, the railway operator may pay only the cost of data transmission, which is mostly similar to the cost of SMS. The retrofit of the rolling stock is simple and less costly. Finally, SATLOC needs less, even no maintenance, and this over its whole life cycle.
These grounds make the cost of a low traffic density line renewal to be up to 10 times less than the solution with the existing ETCS costs. It is also the case for the return on investment. In this way, the operation with SATLOC of a low traffic density line becomes self-sustainable and profitable.
For the railway companies, SATLOC also has other advantages. SATLOC implementation on the network can be phased, progressive, and modular. The system can grow by itself. The profits of one line could generate the resources for equipping other lines. Moreover, when SATLOC provides real-time and accurate information on a train's position and provides the efficient means of data exchange with the trains, the benefits are not only better train traffic management, but also an optimized line system as a whole. After months of testing in real operating conditions, SATLOC has demonstrated the capacity to ensure train control and traffic control in safety, cost efficiency, and full compatibility with ETCS. SATLOC demonstrates that satellite navigation technology is the future for such applications.